Hey guys, so you should have already gotten back your exit ticket from Friday and went over, and now you should be working on your warm-up. I'll give you a couple more minutes to fill that out. First question is, what does inverse mean? And then you are solving two questions underneath that for the variable. So take a second to work on that. Okay, turn to your partner and talk about what the word inverse means. Okay, in math, inverse means opposite. So we're going to be solving equations today, one step in particular. And you need to make sure that you know the opposite operation to solve. So when I talk about multiplication, the inverse operation of multiplication is going to be division. The inverse operation of division is multiplication. The inverse of subtraction is addition, and then the inverse of addition is subtraction. So we need to make sure we do the inverse operation to solve for whatever variable that we need to solve for. So let's go ahead and look at this first one-step equation. It's a minus 32 is equal to negative 18. One of the things I like to do is draw a line down the equal sign to divide the equation into two parts, the left and the right side. If I want to solve for a, I want to isolate a, which means get a by itself. I'm subtracting 32 here. So the opposite of subtraction, what we just talked about, or the inverse of subtraction, is addition. So if I add 32 to this side, that cancels out. Negative 32 plus 32 is 0. But whatever I do to one side, I have to do the other, sort of like a seesaw. So I add 32 on the right. Since this cancels out to 0, the only thing left over on the left side is a. And when I add negative 18 plus 32 together, negative 18 plus 32, I end up getting a positive 14. So the variable a, the quantity, represents 14. 14 minus 32 is negative 18. That's our one-step equation, which we'll be focusing on today. The next, number 3, is going to be solving a two-step equation. And you did this last year, so it should be review. Okay, I'm going to go ahead and isolate the y. So I already know that the negative 7 is a coefficient of that variable. So let's get rid of the number that's not attached to the variable first. In this case, it'd be plus 5. So the opposite of adding 5 is subtracting 5. So whatever I do to one side, I have to do the other. I cancel this side out because plus 5 minus 5 is 0. I have negative 7y left over on the left side and 5 left over on the right side. So now again, we want to get 1y because y has to be by itself. So right now the operation is negative 7 times y. So we're multiplying this. So the opposite of multiplication is division. So I'm going to divide by negative 7, because when I divide negative 7 by negative 7, I end up getting a positive 1, okay, which means that's what I want. I wanted 1y because that's what I'm solving for. Then I'm going to divide that by negative 7. So since I now have 1y on the left side by itself, I divided the right side by negative 7. And when I plug that into my calculator, 5 divided by negative 7 is negative 0.71. Now again, I just rounded that to the nearest thousandth. So my answer here would be negative 0.71. I can plug that back in and check. So we're solving one-step equations today and using models to solve them. So on the next page in your journal, go ahead and head it solving one-step equations, especially using models. Today is August 29th, 2016. And Miss Osborne will come around and hand out this little chart that talks about our inverse operations that we just labeled in our warm-up. And then after you glue that in, make sure you go back and label your page number. So this is my page number 9. And label that in your table of contents as well. Again, this is solving one-step equations. So take a second to do that and glue that in. So as you're looking at this chart, it's properties of equality. Okay, so if you notice the addition property of equality, we add 2 to both sides, which means that they're equal. Okay, subtraction, again, whatever we do to one side, we have to the other, just like my seesaw. Multiplication and division works that same exact way. So, whenever we want to solve for a variable, we have to use our inverse operations. So again, just to write them off to the side, the inverse operation of addition is going to be subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And then the last one, the inverse operation of division, is multiplication. Okay, so again, we need to use the inverse operation to solve for the variable. It's just like working backwards. And the main purpose of solving one-step equations is to make sure that we isolate the variable. And you'll hear me say that a lot. We want to get the variable by itself. Okay, so let's go ahead and start with an example. We'll start off just with one-step equations. Okay, so first example is x minus 56 is equal to 1056. So again, we want to isolate the variable, which means we want to get the variable by itself. So I'm going to go ahead and separate my left and right side. Right now in my equation, I'm subtracting 56, so therefore I'm going to do the inverse, which means I add 56. Negative 56 plus 56 is 0. Okay, so that cancels out. Whatever I do to one side, I have to do to the other. So the only thing left over on the left side is x. And 1056 plus 56 is 1112. So I solved for x, and that should be my answer. Now, one of the ways I can check that is by plugging my answer back into the original equation. So the original equation again was x minus 56 is equal to 1056. I'm going to plug in what I solved for. Again, we use parentheses whenever we plug in a value for a variable. So if I plug in my calculator, 1112 minus 56, that gives me 1056. And that's equal to 1056. If that's a true statement where 1056 is equal to 1056, I know I solved that correctly. Okay, here's another one. Okay, let's solve negative 7x is equal to 90. Again, a one-step equation. We want to get x by itself. So to get x by itself, I need to undo the operation. Right now it's negative 7 times x. So dividing by negative 7 will cancel that out to 1. So that leaves me over with just 1x. Whatever I do to one side, I have to do to the other. So 90 divided by negative 7, if I plug that in my calculator, I end up getting an irrational number. So we're going to round that to the nearest, we'll say hundredth. So again, it's tenths, hundredths. So we're going to round that to negative 12.86. And that would be my answer. Okay, let's just do a couple more. So let's try one with a fraction, or no, we'll do decimal. So let's go ahead and solve 0.75 is equal to n plus 0.6. Okay, so again, we want to isolate the variable, get n by itself. Right now I'm adding 6/10. So I'm going to subtract 6/10 from both sides. Now again, since this is 6/10, this is really 0.6d, so I go ahead and fill in that 0 so I don't get that confused. N is the only thing left over on this side, which is what I'm solving for. And 0.75 minus 0.60 will end up giving me 0.15. So my answer here is 0.15 is equal to n. However, one thing that you need to put a big star by is whenever we have the variable on the right side, we want to make sure that we rewrite it. So the equation reads variable equals that number. Okay, highlight that as well with your highlighter in your pencil pouch. It always should be the variable on the left side is equal to that number. Okay, well that's so important when we work on inequalities coming up soon. So variable is always on the left. Here's another way that it was asked on the EOC a few years back. The question asked if x plus 6 is equal to 21, then find the value of negative 2x. Okay, so there's actually two steps to this problem. They said if x is this, then we need to find the value of negative 2x. So the first step here is we're going to solve for x, because we need to figure out what the value of x is. So again, it's a one-step equation. Right now I'm adding 6, so the inverse would be subtracting 6 on both sides, which leaves me with x is equal to 15. So once I solve for x, now it says find the value of negative 2x. So since I already know what x is, all I have to do is plug it back in to the x over here. So if I have negative 2x, I'm going to plug in with my parentheses 15 in place of the x, and my answer here is negative 30. So again, it's solving a one-step equation. It's just an additional step with using what you solve for, substituting it in, and then finding out the value. Okay, a couple other things I want to hit on before we move on to actually modeling this is with fractions. So let's say it's 3/4 x is equal to negative 20. Now, one of the ways I don't like to deal with fractions, so I'm going to go ahead and change that to a decimal. If you aren't sure what 3/4 is as a decimal, we can easily plug that in our calculator. All you do is 3 divided by 4 to give me 0.75. So 3/4 is 0.75. X equals negative 20. So that's one way, is just changing it to a decimal and then solving. Okay, again, I want to isolate the variable, so right now it's 0.75 times x. So the inverse would be dividing by 0.75 on both sides, which leaves me with x is equal to negative 20 divided by 0.75. So negative 20 divided by 0.75. And this answer is negative 26.6 repeating. That would be my answer. There's another way of doing this. Instead of changing it to a decimal, we can keep it as a fraction. And we're going to be using the reciprocal, which we'll talk about in a second. But what I can tell you is the reciprocal is, what can I multiply 3/4 by to get 1? So the reciprocal is, I just flip-flop these. The denominator, which is 4, is now the numerator. And the numerator, which is 3, is now the denominator. Because when I multiply this, 4 times 3 is 12. 3 times 4 is 12. What does 12 over 12 make? Just 1, which leaves me with my 1x. Okay? So, since I multiply this side by 4/3, I have to multiply this side by 4/3 as well. Just multiplying by the reciprocal. So now if I multiply top times top, negative 20 times 4 is negative 80. Bottom times bottom is 3. Again, my 1x equals this, but it needs to be simplified all the way. So 3 goes into negative 80. Again, negative 26.6 repeating times. So either one is good. Change it to a decimal and solve, or you can multiply by that reciprocal. Let's talk about this reciprocal a little bit more. And define it. Okay, so the reciprocal, the definition for reciprocal is when two numbers are multiplied together and it makes a product of 1. Okay, so if we just throw out a couple examples here, let's say 7/3. Okay, the reciprocal for this is I flip the numerator and the denominator. So now I have 3/7, which ends up being top times top. 7 times 3 is 21. 7 times 3 again is 21, which makes 1. So I know that the reciprocal of 7/3 is 3/7. Try another one, 8/1. Okay, the reciprocal here, I flip the top and the bottom to give me 1/8. Top times top, bottom times bottom is 8/8, which is 1. And even if there's a negative, it still works the same way. So let's try one with negative. Let's have 11/3. Okay, even though the negative is on the denominator, I still multiply by the reciprocal. So this -3 becomes the numerator, and the denominator now is 11. So top times top is -33, because -3 times 11 is -33. 11 times -3 is -33, which ends up making a +1. Two negatives makes a positive. So either way, if there's a negative on the top or bottom, you just still have to flip it to make the product of 1. Okay, the biggest thing is with this reciprocal, okay, again, we can change it to a fraction, which we did up here. But we have to remember that multiplying by the reciprocal is the same thing as dividing. So we take away the division altogether. Multiplying by the reciprocal is the same thing as dividing. Okay, let's go ahead and work on a couple more things you need to know before really moving on to the next step in algebra. Let's solve this one with multiplying by the reciprocal, just so you can see what that looks like. Let's have x/2 is equal to 12. Now we can probably figure this out because again it's a one-step equation. However, let's use multiplying by the reciprocal. So right now I'm dividing by 2. Okay, what number is really sitting in front of that x? It's really a 1. So my numerator is 1, my denominator is 2. So the reciprocal, again, I flip it 2/1, and that's really the same thing. If I'm x divided by 2, multiplying by 2 is the same thing. So that cancels out. Whatever I do to one side, I have to do the other. So I have x is equal to 24. Okay, so that's again just another example of multiplying by the reciprocal. Now this right here, x/2, is actually can be written a couple different ways and meaning the same thing. Now we changed it to 1x over 2. There's actually a couple other ways of doing that. So I want to show you, just so you're not confused. We'll change it up though a little bit. Let's say 4 ways of writing, let's say negative n divided by 3. So take a second and see if you can write 4 other ways where this is the same exact thing. And you can work with the person sitting next to you if you want. Take a second to do that. Okay, one of the ways that this can be written, that means the same thing, is by putting the coefficient in front of it. So it would be negative 1n divided by 3. That represents the same thing. This one doesn't have the 1 written. This one does. Okay, another way you can write this is that negative can go on the top, the bottom, or on the side. So another way, I could keep the 1n on the top, the 3 on the bottom, but instead of having the negative on the top, I can have the negative on the bottom. That represents the same thing, because no matter what, when I divide a positive by a negative, my answer still ends up being negative. Okay, so this one, the negative's on the top, negative's on the bottom. Or you might see it as a fraction with the negative in the middle. And the last way is just pulling the fraction off totally. So I have negative 1/3, and the n just goes here. So all 4 of these ways represents the same thing as that, so you could see it all 4 of those different ways. Okay, so I just wanted to put that into your brains because you'll see that on your homework in the next couple days. Okay, the last step of today is making sure that we can model equations. And when we model equations, we use algebra tiles. So what I'm going to have you do is Miss Osborne's going to come around and hand out to you a bag of algebra tiles. They look like squares and rectangles and little squares. So go ahead and you're going to get a bag of these and go ahead and open them up on your desk and wait until further instructions. So another technique that you're going to be tested on is modeling these equations with algebra tiles. Now our algebra tiles look a lot like our base 10 blocks that you used in elementary school. So in your bag you should have these 3 different shapes. We have a square, a long rod, and then just a little square. Now what these represent, we're going to make a little key so you're aware of what these are. This box, you would think it would represent 100 because of our base 10 blocks. However, okay, the base 10 blocks are used in our elementary school. So this actually represents x squared. The rod, if you think about the rod, notice the rods, when multiplied together, make the x squared, which means the rod represents an x, and then the little square represents just 1 unit. Now if you notice, there's actually 2 sides with 2 different colors. So it doesn't really matter. I always use yellow, green, and blue as the positive side because all the backs are red. Now again, on the EOC it's not color coded for you, so they usually shade it in. So if it's just a rod, they sometimes label it with a positive, which just means a positive x. If it's shaded, we'll use that as a negative x, and that works the same way with just a little square is a positive 1 and a shaded square is a negative 1. So that's our key for modeling. Let's go ahead and actually show you how this is used. Now there's 2 ways they could ask you how to model these equations. The first thing is they can actually give you the equation and ask you to model it using the algebra tiles. So we'll start off with an easy one-step equation. X plus 3 is equal to 10. So let's go ahead and draw this equation. So x is going to represent 1 bar. It's a positive, so I'm going to put a positive x. And then we have 3 positive squares. Okay, so this left side is x plus 3. X plus 3. On the other side, we have positive 10. So I'm going to go ahead and draw 10 positive little squares. Now the way that we're going to represent this by actually solving with these algebra tiles is by working the problem out. So if I go ahead and set this up on my paper, you can just look up here. Okay, I have my x plus 3 positive equals 10 positive. Okay, so if I want to go ahead and solve for x, because that's what we want to solve for, I'm going to get rid of the numbers that are attached to the x side. So to get rid of the positive 3, I'm going to subtract 3. So I'm going to show you it. If I take away 3, these are 0 pairs. So these cancel out, and these cancel out. But again, since I added these 3 red to this side, I have to add 3 red to this side. So I'm going to go ahead and add these 3 red. I'm looking for my 0 pairs, so this can cancel out, this can cancel out, and this can cancel out, which means I have 1x is equal to 1, 2, 3, 4, 5, 6, 7. So x is equal to 7. Okay, so let's go ahead and draw what I just did. So again, first thing I want to get x by itself, so we would subtract 3 here. So I'm going to put 3 shaded little squares. And since these are 0 pairs, I'm going to go ahead and cancel those out. Whatever I do to one side, I have to do to the other. Again, these are 0 pairs. 0 pairs, just when I have one positive, one negative, they cancel out to 0. So I'm going to go ahead and cancel those out. And I'm left over with 1x on the left side is equal to 1, 2, 3, 4, 5, 6, 7. Okay, so that's sort of modeling with the algebra tiles. Let's just do one more. This is when I gave you the equation, you had to draw the algebra tiles. So all your answer choices would be algebra tiles. This is the opposite. This time I'm going to draw it for you. You have to match the equation. Go ahead and draw that out. So this time I'm giving you the algebra tiles. You have to create the equation from this. So go ahead and take a second to write the equation and solve. Okay, you have one positive x here. This is plus or minus 2. Should be minus 2 equals 1, 2, 3, 4, but they're shaded, so remember our shaded represents a negative 1, so equals negative 4. Your equation is x minus 2 is equal to negative 4. So now I want to solve. So to get x by itself, opposite of subtraction is addition. So I'm going to add 2 to both sides, and my answer here is x is equal to negative 2. Okay, we're going to work more on modeling tomorrow with two-step equations, but just to get you familiar with looking at the algebra tiles and matching them up with the equation, we're going to go ahead and play a card game. Okay, so when you're done writing that down, you can put your journal away. You're not going to need that anymore unless you want to look at the key. What Miss Osborne is going to give you is a bag full of cards. And the cards are going to have either an equation on it, or they're going to have the algebra tiles, or some type of model. Okay, so what I want you and your partner to do is go ahead and work together on matching up the equation. So for instance, this probably wouldn't work here because this is 4x plus 4 is equal to 6 minus 3x. What would the equation be for this one right here? Okay, I have 1, 2, 3, 4 x's. These actually show if they're negative or positive by labeling them. So 4x minus 1 equals what? Looks like negative 9. So 4x minus 1 equals negative 9. I'm looking for that card. And where is it? There it is. 4x minus 1 equals 9. So I'm going to go ahead and just pair those up and put those aside. Okay, so go ahead and go through the whole bag when Miss Osborne gives it to you and just match up. Here's another one. It's not algebra tiles, but it's a different type of modeling. This was actually on the EOC one year. So again, you're using the same exact knowledge. So go ahead and match those up. And then if extra time is allowed before that bell rings, because there's no homework today, you're very welcome. Then, once you have them matched up, shuffle them up, and then you can play memory. So old school memory, okay, which means you just line them up. Make sure you keep them in order, though. And then you'll just take turns matching up. Okay, well, this is whatever, and that doesn't match. So I'm going to flip it back over, see who can get the most pairs. Okay, and we will, no homework today, so you will be ready to go tomorrow first thing with your warm-up. So have a great day.